It's like 25% of students do that now. Okay, let's take a look at the answers. Take a look at the answers. Good. Thank God, you know. Figuratively, of course, I'm not really religious, but as a expression, good. Remains the same. Really happy that all of you chose this answer. Let us move on. So I want to actually start talking about something else. We're still going to continue our conservation of energy. We're still going to continue that. But I want you guys to, we're going to continue talking about conservation of energy. But let me explain this gift first, or rather, let me explain this question. If the law of conservation of energy is to be believed, why do you think objects don't go back to the same height it was originally dropped at? For example, let me just go back to the simulation. That's not it. Let's take, for example, this lady, this skateboarder. All right, let's actually give her a larger mass. You see that a skateboarder, when they let go, well, in this simulation at least, when they're let go, you see that the skateboarder reaches the same height they were launched at, or at the same height they were dropped. Why don't everyday objects behave like that? And I'm not talking, don't answer with curvature. The curvature is not the answer. The fact that it's a ramp has nothing to do with it. Because gravity is pulling it. Again, guys, do I expect you guys to get a correct answer? I don't, because I'm just introing it to you right now, right? I'm just trying to get like what you guys think. But I am going to comment on your answers. I don't know who wrote these answers, but I will comment on them. Because gravity pulls everything down. But if gravity was pulling you down, gravity is pulling the skateboarder down too. And the skateboard has a lot of potential energy, and it gets converted to kinetic energy. But the skateboard is not slowly dropping. They start to slow down, but you're just describing it. Why is it though? They start to slow down, force due to gravity and normal force. But again, the force due to gravity and normal force is still apparent in this simulation too. K goes down over time, but again, guys, is gravity not acting on the skateboarder? Is gravity not acting on the skateboarder as well? Because of its weight? Does this skateboarder not have a weight as well? Which is your force due to gravity. Weight is force due to gravity. Because they lose their energy due to friction? I like this answer, you're close. You're not entirely correct. Because gravity changes over time? It does, but by very minuscule amounts. Not enough to change. P is turned into KE. While that is a fact, why does the ball just completely stop? Because if you think about it, at the end, there's no more kinetic energy. So where did that energy go? This is a fact, but you're not really coming up with an answer to the question. Energy cannot be created or destroyed. That's not really answering the question. Am I going crazy, guys? Well, I don't expect the correct answer, but I expect maybe answers that are on point, like trying to answer the question. I am, by the way, guys, I am going to take one of these polls as attendance.
I joined a bit late, so like couldn't answer the poll.
Huh?
I said I joined a bit late, so I couldn't like answer the poll. I joined like 190, 118.
Oh. Didn't we start at that time? We did.
Is it locked? Oh, never mind.
No, it's not locked. Okay. So I had this happens in every class. This happened in every class, right? People said gravity. But when people say gravity, they're missing, it seems to me that people don't really understand your potential energy. The force of gravity is your potential energy. It's your potential of gravity to do work. So gravity is already pulling you down, but there's a transfer of energy to kinetic energy here. There's one close answer, and they're not entirely correct. I mean, they're correct in one part, but not correct in the other. One of these answers are. But I want you guys to think about it for a second, okay? Just keep this question in mind. We're not going to answer it yet. Why ruin the fun, right? Why ruin the fun, right? So let's move on to the next question. Keep the question in mind, by the way, guys. Let's talk about this question. So I want you guys to ignore the fact that the bike goes up a bit. You are only caring about right at the beginning when it has a velocity, and the end. You only care about the beginning and end. The end being the fact that the bike completely stops. I spelled break wrong. I am very well aware of that. I mistyped break. There's a typo. I spelled it wrong. I wish I spelled it correct, but alas, I did not. Alas, I did not. So now that we've established our beginning and end, does the passenger and bike's potential energy change from beginning to end? Is there any change at all? Relative to the ground, you can assume that their height is 0. That the height at the beginning is 0 and the height at the end is 0, okay? That's something you guys can assume. I'm gonna tell you right now, you can assume both of these things. And yeah, you can assume both of these things. Yes, doesn't answer this doesn't answer the question, guys. Again, you're answering the question. Yes, because it's creating friction does not answer the question. I am going to be taking one of these random polls as attendance. I do have follow-up polls. There are more polls. Polls.
You post it?
It's in the chat. Potential energy doesn't change because height doesn't change. Kinetic energy changes because velocity changes. Yes, it does. It increases and kinetic energy decreases. I'm going to assume that you're thinking that potential energy increases. No, it does not because it's leveled and potential and kinetic takes place up and down based on pig. Like, I'm not sure what that means. Because you're stopping because there's no more movement. But which one though? Again, there are two questions here, potential and kinetic. Did your English teacher not remind you guys to answer the question? What did your English teacher teach you guys? You're answering the question. There's a question to be answered.
So you're doubting my English teacher?
Yes, I
Bro, you
am.
talking down our English teacher, bro.
I am.
I don't
I am
think you want
doubting.
all of that smoke, you know.
I am doubting them. I don't know, but like when you guys are writing answers, usually you write answers to answer the question, right? You're staying on topic. John, that's not useless. That's really important. You want to be able to analyze information. You got to go now and pick up your little brother, sure. Analyze information that's basically what you guys are doing in physics. You know that, right? Every day. Guys. You know, when I was reading last year, I was reading student responses, and students would always repeat like half of the question in their answers. I'm like, is this something your English teacher taught you? And I didn't really like that. I didn't like how students couldn't improvise and come up and paraphrase their answers. But now I'm starting to think that maybe you guys should repeat half of the question in your answers. Kinetic energy decreases loss of heat. So I like some of you guys. I like some of these answers. Okay, and we'll talk about this now. This is the class that's actually giving me some of the correct, more than a decent amount of you are giving me some really good answers. So let's think about it, guys. If the beginning height is 0 and your ending height is 0, then you don't change. Your potential energy doesn't change. If you're telling me my potential energy changes, you're not understanding the fundamental mathematical formula, which is mgh. If your height doesn't change, you have no potential energy. So the potential energy at the beginning is 0, and the potential energy, the gravitational potential energy, to be very specific, is 0 as well. But your kinetic energy, there's definitely kinetic energy. It's definitely greater than 0. You are moving. You have a velocity. Your kinetic energy is greater than 0 at the beginning. But at the end, when you've completely stopped, your kinetic energy is now 0. So this is the conclusion you guys should have went into. My kinetic energy definitely changes. It decreases. I completely stop. But your gravitational potential energy, there is no change in potential energy here. You are still at a height of 0 relative to the ground. If your height does not change, your gravitational potential energy does not change. But here's the question. But if I really like some of these answers, by the way. I'm glad you guys are participating. It really brings like I'm really happy. I'm really happy that I see like some of these answers. I really appreciate your answers, guys. Let's go to the next slide. So again, this next question is, well, if the conservation of energy is law, and it definitely is, it cannot be broken, it is true fundamentally for the entire universe. If where do you think the energy goes into, right? Because I'm losing kinetic energy here. I am 100% losing kinetic energy from beginning to end. My bike stops. But my potential energy does not change. So where is all this energy lost? Where is all this energy going into? Conservation of energy law is concrete. You cannot be broken. I think the GIF is very descriptive, as some of you guys have already figured out. I think the GIF is extremely descriptive and good at explaining where all this energy goes into. The thing is, potential energy, you're still at zero, so there's not much potential energy going to, there's no transfer of potential energy. We'll talk about that, whoever messaged me privately, I'll talk about it. Do not worry a single thing. A single thing? I don't think that's correct. Do not worry about a single thing. That's correct grammar. All right. Goes back into the wheels. Kinetic energy decreases, heat energy increases. Okay. So I think most of you have figured it out yet, either if you looked on the screen, the answers, or you've just figured it out just now, we're still looking at the GIF. But yes, energy is lost due to various things. Like, for example, heat, right? Because you can clearly see. Can I go to my next slide? Well, what's happening here? I really hate my laptop. But I'm just being spoiled right now because I know that you guys only have one screens too. It's just that when I'm teaching with one screen, it's just really annoying to teach with one screen only. But I understand, I'm being spoiled here. I know that you guys, most of you guys only have one screen anyway. So I apologize. So guys, you can clearly see that the room temperature of this room is around 23 degrees Celsius. And as the bike brakes, you see that the temperature increases. Look at this. There's a temperature increase. And it's like somewhere around here. Now the temperature has increased. That's friction. That's friction, guys. And friction, if you know, when you rub two surfaces together, you get heat. So all this kinetic energy that's lost, because clearly we are losing kinetic energy, it's being transferred into heat energy. It's being lost as heat energy. It's not being transferred into potential energy. It's being transferred into heat, thermal energy. We'll call it thermal energy. And here we go back to our basketball example. Now, I really don't like repeating off slides. I'm not sure if I've made that apparent to you guys, but repeating off slides gives me trauma because it reminds me of when my professors in university just repeated off their slides. So it gives me a little bit of trauma there. And I usually try not to, but I have to for this one. So far in our class, we've been thinking of things, you've been given problems that say that word like neglect friction, ignore air resistance, right? And those are situations which make you assume that the world is perfect. And there are actually more imperfect things that happen in your questions, right? Not even including friction, there are actually more impossible things, but the world isn't perfect, right? Real life isn't perfect. You cannot get a perfect transfer of energy between gravitational potential energy and kinetic. There is no perfect transfer. Some of these energies are lost somewhere else. So what we're gonna do is we're going to call everything that's not gravitational potential energy and kinetic energy internal energy. Because there are many different types of sources that we can lose energy to. Because there are too many, we're just going to classify everything as internal energy. Anything that's not PE, anything that's not KE, we're going to call it internal energy. And Q is internal energy. So let's take a look at this basketball. Let's take a look at this basketball example. So, actually, I don't like that color. 5 joules. So let's say at the beginning, this ball is falling down, right? So you have this ball, it's falling down. The first image, we're looking at the first image, by the way, guys. So this ball is falling down and you have 5 joules of energy. You have 5 joules of energy. This ball falls down further, some of the potential energy gets transferred into kinetic energy, right? You still have 5 joules of energy. And just before it hits the ground, just before the ball hits the ground, like 0.000001 second just before it hits the ground, all your energy has now been converted into kinetic energy. And so the total amount of energy here is 5 joules. But now once the ball has hit the ground, once the ball hits the ground, the ball compresses, right? That compression creates heat. Atoms start vibrating. You hit the ground. Some of that energy is lost due to friction, right? As you're coming down, you're hitting air molecules, air resistance. There's loss of energy there. When the basketball hits the ground, the basketball makes sound, right? There's a sound that occurs when a basketball hits the ground. Some of that energy is lost as sound energy. What is sound energy? basically the vibrations between air molecules. Something has to cause those molecules to vibrate. That's just the compression of everything around it. So you're losing various amounts of energy here. So in this hypothetical diagram, I've now lost more than 50% of my overall energy due to other sources, heat, friction. But my total energy here is still 5 joules. My kinetic energy decreases as I go back up. Sure. But you don't go up as high. How are you going to go up as high if you only have 2 joules of kinetic energy? So you don't reach as high of a height anymore. And so you drop back down, but you still have 5 joules of energy. And then eventually, after multiple bounces, your ball completely stops. And all of your energy has now been lost. But the total energy remains the same. You still overall have 5 joules of energy here. Are there any questions about this? This is like very important. Very important. What else do I have to say? Oh yeah. Someone asked me where in one of the other classes where the word energy comes from. This universe was born with amount of energy. Where does the earth get its energy? The source of all energy, or most of it, I mean, gravity is a part of it too, right? Is from the sun, right? Sunlight. Sunlight gives like the bottom of the food chain energy, plants, vegetables, green, trees. And that supports our ecosystem. But that's in like the form of chemical energy. Where does the sun get the energy? When hydrogen atoms collide. The bonds between the atoms, when they form helium, and energy is expelled, lost as photons. Okay. I do want to go into this, but before we go into this, yes, energy, it just transfers, guys. This is your attendance wall. Attendance wall. Rant. What I want to talk about. Oh yeah, this. So obviously, if you haven't realized, because you have a life other than school, me too. Except school is your full-time job. If you want a better future. That argument is like a moot point. Because you have a life other than school, or you're not gonna have much of a life. See, this argument is really bad because you're telling me you're going to get a better life in the future by not having school. That's a really bad argument. You're in school for a better life in the future. Unless you don't care about that, right? Who's going to take care of your parents when they get old? In this society, it's inevitable. You need to let's take a look at this though. So let's take a look at how friction affects the government. Okay. All right. Let's do something serious now. So now this is going to resemble real life. I'm going to actually add friction to this ramp now. So this is actually going to start resembling real life. And I want you to take a look at the diagram. So you're slowly losing energy due to heat energy, right? Because there's friction between the wheels and the ramp. There's friction between the wheels and the ramp. So as you slowly go up and down, you slowly lose energy, right? You slowly lose energy, and eventually you stop. Increase the friction. And eventually, all your energy is lost as heat energy, right? Eventually. Your roller coasters work the same exact way. They work the same exact way. You go up to a point, potential energy, you get a lot of potential energy, all that turns into kinetic energy. But along the path of the roller coaster, you lose energy due to friction, right? Along the path of the roller coaster. Same thing with this video, guys. Same thing with this video. Same thing with this video. All these people are jumping from a higher height, right? All these things are jumping from a higher height. They have potential energy. They hit the trampoline. They lose energy due to various forms, right? And then they get back to a lower height, right? They get back to a lower height. And so there's loss of energy there. And this is perfectly visible in this video. I think this is a good representation. All right. Just so you guys know, there's a test on April 12th. We're coming near the end of this unit. We're actually on 5.5 right now. We do need to do two more lessons. So we're going to spend the week after spring break on 5.6 and 5.7. And then we're going to have your test on the following Monday, which is the 12th of April.
So like review or new topics.
I'm sorry?
So review or new topics.
Wait, what?
Are we getting review or like new topics? What are we doing?
No. We're getting new topics.
Oh, okay.
5.6 and 5.7, yeah. Not much. We're going to continue this tomorrow, obviously, but tomorrow is practice questions. Tomorrow we're going to do practice questions. Oh, yeah, this one. Anyway, I'll see you guys tomorrow, guys, okay? We'll continue this tomorrow. Bye-bye, guys.
Have a good day.
You too.
You can FaceTime me in the shower.